Okay, there's a little bit of racket going on in the hall. Hopefully that won't disturb us, but let's look at this. And I'll comment that the high resolution video on the last video didn't get done. Memory card ran out of space. I got confused on the rotation of the memory cards. Okay, that's irrelevant. Quick summary and more discussion. We've already seen how to construct the value of the tangent, the line segment representing the value of the tangent for 1 point. Now, I've sketched the constructions not very accurately, but there's a trend to these constructions, especially as we move from this one to this one to this one. So, I begin with, I don't think I ever did this point. Actually, yeah, I did. Okay. I'm confusing myself. Okay, cosine is this big, so I sketch this segment. Sketch my unit segment. Extend this side to a unit segment. Sketch my hypotenuse. Actually managed a pretty good straight line there, the only one. And now I project from here down to here. I get reciprocal of the cosine for reasons that you should understand very well. I take the reciprocal of the cosine, which I didn't label over here, so let's label it. This is reciprocal of cosine. And 1 here. And then I take my value of the sine. Now, at this point, the sine is small, so right there it is. I complete this triangle with the side parallel to the hypotenuse. Didn't do a really great job of that. But in any case, I then get a line segment here whose value is that of the tangent. Now I move to this point. Okay. Now between this point and this point, the value of the cosine has gotten smaller, so that this side here, the yellow segment, is quite a bit shorter than the yellow segment here. The purple segment representing 1 is the same length it's always been, same length it is here. Probably didn't sketch it all that well, but that's what it is. And since this side is shorter and this side is the same as before, the hypotenuse is going to be a lot steeper. So that when I construct my unit distance here, and of course, well, I'm not going to label it. When I construct my unit distance here, I have to go a lot further to get down to the graph, so that my reciprocal of the cosine is bigger than it was before. And that's natural, since I'm taking the reciprocal of a smaller number than before. Okay, now, when I construct my graph to multiply the sine by reciprocal cosine, remember my sine is going to go here. My reciprocal cosine will be this green segment, represented by this green segment. The reciprocal cosine is a lot bigger. The unit distance is still the same as what it was, so that this segment is not nearly as steep as it was here or here, as it was here or here in our construction of the value of the tangent. So that when we take our larger value of the sine and construct this triangle with sides parallel to this one, this side is a lot less steep than this, so we got to go a lot further to go any distance in the vertical direction. And we have a bigger vertical distance because we have a bigger sine, so that our value of the tangent, for both reasons, for the fact that this slope is less and the fact that the sine is bigger, gives us a considerably bigger value of the tangent, which we represent here. So we represent this tangent here, we represent this value of the tangent here, and then we ask what's going to happen as we continue moving to the right. Well, let's not even think about what's going to happen when we cross this point where the value of the cosine is 0. We'll observe that when the cosine is 0, the tangent is undefined, because you can't divide by 0. Division by 0 is undefined for many good reasons. as we approach this point on the horizontal axis, the value of the cosine will approach 0. Means the cosine is going to get smaller and smaller and smaller. No limit to how small the cosine is going to get. So that when we first of all construct this triangle, this side here is going to shrink. It's going to shrink down towards 0. Now 1 is still as big as it was, and that's going to make the hypotenuse extremely steep. Okay, hypotenuse gets really steep. 1 is still as big as it always was. So going from this point down to where we meet the extended hypotenuse, we're going to have to go a long way. Okay, we could easily, if we move twice as close from this point to this point, probably have to go several feet to meet the cosine, or to meet the hypotenuse, giving us a really big value for reciprocal cosine. But there's no limit to how big the reciprocal cosine can get, because there's no limit to how short this side can get, meaning there's no limit to how steep the hypotenuse can get. Okay? Then when we construct this triangle, 1 is always going to be the same as it was. The reciprocal cosine is going to get huge. The hypotenuse is going to get very shallow. The sine doesn't get huge. The sine can't be bigger than, sine can't be bigger than this. Okay, biggest sine we're going to get is here. But since this green side is going to extend as far as we wish, if we get close enough, to meet that green side with a hypotenuse parallel to this hypotenuse, we're going to have to go a long, long ways. And there's no limit to how shallow this can get, so there's no limit to how far we got to go to meet that horizontal side of the triangle, meaning there's no limit to how big the tangent can get, so that the value of the tangent exceeds all bounds. The implication for the graph is that we have a vertical asymptote at this horizontal coordinate. Then symmetry arguments and so forth that I'm going to leave to you. I'm not going to explain all this now, but you should thoroughly explain it to yourself if you want to really understand this. If you want to be able to think thoughts that you wouldn't otherwise be able to think, this is very good exercise. And these are very useful thoughts, okay? Help you solve problems that other people can't solve, or problems that you would not otherwise be able to solve. There's always somebody out there who can solve it. So you can't necessarily expect to beat everybody, but if you're competitive, it's going to give you a big advantage to think through this, okay? Think through why the graph here has to look the way it does. Okay, in terms of the reference circle, in terms of the values of the sine and cosine, one thing I'll tell you is that the cosine goes negative here, right? And the sine remains positive, so the values are going to have to be negative. And why does a graph have the shape it does, okay? So there's a geometric construction of the tangent function. And of course, we haven't completed the geometric construction. You have to do this for an infinite number of points, but you can do it for as many points as you have time. And you should actually do this construction, do these constructions for at least 3 or 4 points.